Hi, everyone. Happy Thursday. I'm super excited for today's show because we have special and exceptional guest today. It's none other than Lior Gavish, CDO of Monte Carlo, and Ryan Kearns, lead data scientist at Monte Carlo. We'll be discussing about data downtime, data observability, about the new book that a few days back I announced about, which was Data Quality Fundamentals, a practitioner's guide to building trustworthy data pipelines, and much more. You also have a chance to win the book, so do not forget to type in hashtag Monte Carlo to win the guide. All you need to do is type this in the chat and you'll enter the raffle. I'll make sure that I'm letting the folks know about it in intervals as they join, but for sure, if you're wanting a print copy, don't forget to type in hashtag Monte Carlo. We'll be announcing two winners on the show, one towards the mid of the show and one towards the end. So that's going to happen. A little about our guest. Lior Gavish is the CDO, as I mentioned, and co-founder of Monte Carlo, a data reliability company, and creator of the industry's first data observability platform backed by Axel, Redpoint Ventures, GGB, Iconic Growth, Salesforce Ventures, and IVPP. So prior to Monte Carlo, Lior co-founded cybersecurity startup Sukasa, which was acquired by Barukada in 2016. At Barukada, Lior was SVP of engineering, launching award-winning ML products for fraud prevention. Lior holds an MBA from Stanford and MSc in computer science from Tel Aviv University. Ryan Kearns, our second guest, is a founding data scientist at Monte Carlo, where he develops machine learning algorithms for the company's data observability platform. Together with CEO and co-founder Bob Moses, he instructed the first ever course on data observability with O'Reilly Media, the first tutorial on the subject using out-of-the-box SQL. Ryan recently graduated from Stanford University, where he earned a BS in computer science and BA in philosophy. Congratulations, Ryan. All right, I already see folks typing in Monte Carlo. Do not forget to type in the right spelling, otherwise the raffle won't pick up the entry. So Sean, don't forget to type in Monte Carlo with the right spelling. But Amanda is here. Hi everyone. Thank you for joining in. And without any further ado, let's bring up our guests here. All right. Hey, Lior, welcome to the Rocket Show. Hey, Ryan, welcome.
Hi, Robert. Very nice to be here.
Hey, Robert. Great to be here.
Have you both. Yeah, it's such a pleasure to have you both here. And obviously, today I'm super excited to discuss about data downtime, data observability, and about the recent release, Data Quality Fundamentals by O'Reilly. So can't wait to hear more about it. We also have Sharon here from O'Reilly. So thanks for joining in, Sharon. All right. Yeah, Lior, Ryan, I know I gave a little background about you guys, but why not introduce yourself and tell us more, about what you do at Monte Carlo and a little about Monte Carlo as well. Maybe Lior.
Should I go first? Okay. Hi, everybody. I'm Lior, one of the co-founders of Monte Carlo. I started a company with Bar, our CEO. It was about 3 years ago. I mostly focus on the product and engineering side. I'm an engineer by training, turned data scientist at some point, and data engineer by necessity. And over the years, just experienced so much data downtime. We'll talk about it later, but experienced so much downtime on in the things I was building, and at some point, when I partnered with Bar on this, it kind of seemed obvious that this is a problem that's going to be that actually everybody experiences, everybody that's working with data, and that it's going to be extremely valuable and interesting to try to solve it in a more consistent and methodical way across organizations, and so we started Monte Carlo around that idea.
Okay, Ryan.
Yeah. So my story is a bit more recent than Lior's with Monte Carlo. I actually got in touch with Lior actually right around 2 years ago. I had been working at GGB, which was the venture firm participating in the Series A of Monte Carlo at the time. And I was looking for a way to spend some time that wasn't at school during the pandemic. And some of my contacts at GGV said, we're really excited about this young upstart company, Monte Carlo. They gave me Lior's email address, and here I am 2 years later. So I've worn the data engineer hat here. I've done a bit of kind of back end and front end work, and then I kind of fell into the data science stuff early on into the product's development when we were starting, our initial anomaly detection techniques. So I've engineered some of the algorithms that do a lot of our monitoring capabilities. So today I'm working on a lot of those and a lot of like custom built root cause analysis stuff at the company as well.
Okay, that's a pretty cool story, Ryan. Obviously working for Monte Carlo is huge. So fantastic job there and good stuff that you're doing. You mentioned you're a data engineer at heart. So obviously my next question was around that itself, where, how do you see data engineering space evolve over the last few years? Like we've seen so many new tools, so many new categories joining in. So would love to learn more about it from you both. Maybe Lior, you can go first.
I can go first. Okay. Um, it's quite exciting. I think in the last few years, data engineering has really become glorious, and for a good reason. Suddenly you see everybody wanting to be a data engineer, which is really, really exciting. I think what's driving this is just the huge growth in using data to do a lot of things in business, right? And there's, starting from the analytics, which is always there, but is now becoming more and more prevalent with people adopting, dashboards and data for literally every part of business and using it daily. But also, we've seen the prevalence of machine learning rising, right? People trying to use predictive methods to power, features in their products or parts of their business, like marketing and pricing and whatnot. So that's been exciting too. And then we've increasingly seen the adoption of data and analytics as a core part of digital products, right? And data gets sold essentially to customers, and there's strong dependence on data. And so with all of that, we're seeing companies having to take their data pipelines much more seriously, right? It's no longer that you run a query on the data warehouse, put it in a binder, and hand it over to someone once a quarter. You're actually using data all the time, every day, for a variety of different use cases. And so data engineering has become this important foundation of like, how do you even do that at scale? Like, how do you get all of the different data sources that you have together? How do you transform and prepare that data to be used? And how, and even more important, like, how do you enable like the business to make use of that data, right? Like we're increasingly seeing not just data engineering team, but actually data platform teams that are building a foundation on which analysts and data scientists and analytics engineers and a lot of other people are actually building data application or data products, what we call data products, right? And data engineering really is at the core of all of that. And in the last few years, we've just seen that recognition and that of the importance of the role. And we've seen like very smart people moving over from software engineering or from the analytics side and becoming data engineers and becoming really professionals in that space. And we've also seen the stack kind of evolving really nicely, right? With the quote unquote modern data stack, really giving data engineers superpowers that they didn't used to have. So that's my take on data engineering.
Okay, that's pretty interesting, and those were valuable insights out there, Lior. So thanks for sharing those. Ryan, how do you see it? Because I know for a fact it's been a while since you've been doing this now. So how did you see that this almost 2 or 3 years back, and how do you look at it right now?
Yeah, that's a great question. Even in the time Monte Carlo's been around, in the time we've been, working on data quality fundamentals, there's been quite a development. I think Lior encapsulates it very well with this shift towards, more cloud native companies in the space being truly data driven in the way they run their business, and that has these immediate effects on like the data engineering profession. And if you're going to be data driven, you need more data, you need it faster, and you need the format to be more flexible. So you need to be able to accept, different types of payloads, different types from various endpoints, and integrate those all together, at scale, at speed, with like high uptime. And so this is really the perfect storm for data observability to take shape, because you've got these pipelines that are really hard to maintain. They scale faster than they can be sort of maintained with the human eye, so to speak. And this is kind of the perfect platform to, you find this pain of my data is down, data is inaccurate. Now I can't run my business. It gets to the level of impacting the bottom line, the ability for the business to do its work. And I think data observability was sort of the inevitable response to that move towards, more cloud native, more at scale, high speed, and flexible formats, data lake formats, and what have you.
Okay. Those are pretty cool insights, Ryan. Thanks for sharing those. Also, I know there are a few questions in the audience. I'm surely gonna pick, so don't hesitate, guys, to ask questions. I'm starving them, so I'll be asking Lior and Ryan as we go ahead. But to obviously, we've learned, we've heard a lot about data downtime from Monte Carlo, and I'm sure a lot of the folks who are joining us today have this question: what is data downtime? So can we start with data downtime and get into the weeds?
Sure. Yeah, I could go ahead. It's actually pretty simple. But by the way, before I clearly define it, I'll just say, we borrowed. We can't claim credit for the downtime word. We actually borrowed it from DevOps, where it's kind of a really well established term. Everybody knows what it means when an application is down, or when a mobile app is down, or a service is down, right? And teams measure their downtime to understand how well they're doing from a reliability perspective, and to manage it to certain standards of quality or certain SLAs that their business requires, right? And we've borrowed the term downtime and applied it into the data world. We think, it's equally important, as Ryan mentioned, like when a business relies on data and data product to run and to deliver its own services, you actually care about times where your data is, wrong or inaccurate, or, otherwise erroneous, right? Or otherwise does not meet the quality standards that the consumer is expecting. And so, defining those times where you're basically letting your customers down, in a sense, and measuring it systematically, and managing it to an acceptable level, is really what data ops is about. And data downtime is essentially the most important KPI, right? Eventually, like, you want to know that there's as little time as possible where your consumers can't use the data that you are producing as a data team.
Okay. Yeah, I think that sounds pretty straightforward. Ryan, your thoughts?
Yeah, I've actually just got a good example of this. I think Lior's encapsulated it very well. There's one, actually, we were talking about it at Monte Carlo earlier, 538, which is this popular polling platform for kind of US political races. Right now, they're covering a lot of the midterm polling that's going on for the upcoming midterm election. They actually issued a public correction to one of their forecasts to do with the midterm elections, where they had missed a data set in the process of formatting this polling result, this speculation. and they made a series of corrections to their actual polls as a response to that. Some of the changes are as big as 15 percentage points, and they flip the favored candidate for a number of congressional races. And so this is kind of a good example highlighting, 538 data really is their product. They rely on accurate polling insights to show this to their customers. Their data was down. As a result, they were delivering erroneous predictions for like a large number of cases. And they were really good about it. They noticed it. They found the actual root cause of their issue and fixed it retroactively. But those are the types of things we're talking about. Data down means that the product really can't work if it's data driven.
Yeah, I think very nice example out there, and thanks for that. Awesome. We'll be taking a few questions. Let's see. We have a question from a student here, Ryan. I think you might be the one who could answer this one because you started back then. So, being a student, what is the best way to start your career in data observability? Very interesting.
Yeah, this is a great question. I kind of stumbled my way into it, and so maybe the path I took is maybe hard to replicate. But I studied computer science in school, and so I did actually a focus on artificial intelligence. And so in school, I did a lot of kind of, I guess you could say, the more academic venues for AI research. So I did a lot of deep networks, a lot of natural language processing, and RNNs, CNNs, like computer vision type tasks, that whole assortment. And I sort of made the migration to data observability by, I guess, applying a lot of those skills. I use a lot of Python in my job, and I learned that at school. But I also learned SQL here at Monte Carlo, actually. And now the majority of my job is done in SQL. I wouldn't recommend that pathway. I'd say if you can be taught it in a more structured setting, probably be a bit faster than I was. So there are sort of tools of the trade, when it comes to knowing SQL, knowing Python, and how to run experiments in the notebook format. There's a whole technical rabbit hole we could go down here, but I'd say at a high level though, just being kind of aware of the trends, of the tools that people are using. The data space, all of tech moves extremely fast, and so you'll hear about this stack constantly changing. Being on top of that is kind of hard, but it's generally a good idea to be aware of what tools are used, and then ultimately, the core building blocks, being familiar with Python and like pick your favorite programming language of choice, plus SQL and some database concepts, are a very solid way to build kind of the technical skills there. I can really speak to the technical side. Obviously, there's a lot of other stuff that goes on at a company building a data observability product, but that's my high level advice.
Yeah, I'm sure it helps Daksh to learn more about it and good advice there, Ryan. Thanks for that. Also, my next question would be, how did you guys come up with the idea to tackle the problem of data downtime? Like, what was the starting point that you decided that, okay, we'll be tackling this problem? Maybe
great question. So I'll give a little bit of my background, and that kind of sets the stage of how we ended up working on it. And Bar, my co-founder, would have a kind of a similar story. So after school, I started a company, like you said, Ravit, in the cybersecurity space. And if anyone here has worked on cybersecurity, modern cybersecurity is a lot about data at the end of the day, right? It's about collecting data and putting together the right pipelines, right analytics to be able to identify patterns and issues that indicate a security problem. You might even use machine learning to do that, right? Though not exclusively. You can also use kind of more standard analytics. And so over the years, I ended up spending a lot of my time on solving certain cases of fraud of pretty targeted and severe kinds of fraud that are hard to tackle using the more traditional kind of rule-based approaches to fraud, just because attackers started personalizing their attacks and making them like very unique. You can no longer detect attacks just by looking for what you've seen in the past. It doesn't work anymore, right?
Right.
And so we were using a data approach to it, a machine learning first approach to it. The company ended up being acquired by Barracuda, which is a public cybersecurity firm back in the days. I ended up leading the engineering team there, and our system was highly reliant on data, right? If the data pipelines, if the machine learning models don't work as expected, the system is just useless, right? And so, you know, it did happen. Unfortunately, like I have to be honest, it did happen. We did, you know, disappoint our customers in certain cases, and when it happens, you know, we're exposing them to severe kinds of fraud that are very costly for them, right? And I started thinking about those times where we disappointed our customers. It was more often than not because of what we now call data downtime, right? And when you ask yourself, why does this happen? You know, because usually downtime is because your servers are down, or you know, put a bug in production, or your database is overloaded or whatnot. Why is it coming from the, you know, from the data reliability aspects of the system? The answer to me was kind of, that was a light bulb moment for me. It's because we have pretty robust methodologies and tools to tackle the application and infra side, right? We can manage it to like a certain level that's acceptable to us. But on the data side, we were flying blind. We were kind of shipping things and hoping they will work. Obviously, at some scale, that doesn't fly anymore. And so that was kind of an interesting observation. And Bar had a similar experience, actually more on the analytics side. She was helping teams use data to do customer success. And the obvious conclusion was that Bar and I really suck at what we do. But then we thought maybe there's another explanation. We went out there and actually talked to over 100 data teams, and we figured out we weren't alone, right? Like we just saw, you know, everybody's struggling with the same problems. Everyone's finding it a nightmare. Everyone's like not sleeping at night, worrying about the, you know, angry Slack messages they're going to get in the morning when things, you know, don't work. And so we thought, hey, you know, that maybe there's an opportunity to apply some of what we learned and build a solution that can be adopted, right? And if you think about it, Monte Carlo is not just a solution; it's also, you know, we had to shape the methodology. Like there was no established manner of doing data reliability, and so Monte Carlo, you know, when we started, we actually started from like, okay, how do you put together a process and an organization to actually deliver a reliable data product? And then from that, like, what are the tools that that people are going to need to deliver on that? And then observability was kind of like the obvious, you know, building block that we thought was most impactful and most important. And that's kind of where it all started. And then we met Ryan, and he completely crushed it and built an amazing solution.
Yeah, and I would love to hear your experience as well when you heard about it and when you obviously learned from, you know, the problems that Lior and Bor obviously identified, and, you know, obviously after talking to so many data teams, it's kind of interesting because you have those insights ready, but at the same time now you have to work on it to make sure that you're going and solving those problems. So how was that for you? And coming from obviously if I'm not wrong, you were at the university, and then obviously you kind of get into it, and you start tackling, you start thinking at a corporate level. So how does that work, and how was that for you?
Yeah, it's a big wake up call, actually, going straight into the industry and working at this scale, at this speed. Like I mentioned, like the real time uptime is something you don't get to see in school so much. So I was very familiar with this maybe old fashioned concept for data science, where you've got this purified data set that sort of arrives magically in the form of a CSV file. And you can take that and parse it and run detection, or you can run prediction with some really high powered models. And like the beauty of that problem is in modeling the algorithm correctly. And I sort of joined industry and immediately learned that that was a really small piece of the puzzle, that actually the majority of the value was found in arriving at that pristine CSV file to begin with. It's like not something you take for granted. It's really hard to produce data sets that regularly are up to date, that have kind of a full representative sample, right? That you can actually do meaningful machine learning on. And yeah, like I think Lior and Bar deserve this enormous amount of credit for conceptualizing this problem so well, before even putting pen to paper, so to speak, or starting to write a single line of code. They had done such a good job sort of encapsulating the problem for businesses. And it was sort of up to us on product to turn that into a real vision. Like, how do you actually solve for data observability in a way that every team can understand, that's not just for this one group of people who've thought about it? And that's still evolving today. I think also the book is a big step towards formalizing some of those notions, but it's very much still an active conversation. We're learning about how these building blocks fit together, and what the best responses are, improving time to detection, time to resolution, and prevention of data downtime. It's a big space. Yeah.
Yeah, no, I think 100%.
I just have to add, like, one thing that Ryan does extremely well is he is, and this is something that we care a lot about as a company, is very customer oriented, right? This is and this is something that I think it's not obvious, at least wasn't obvious to me coming out of school, is that we all come in with a lot of hypotheses and a lot of ideas, and some of them are good, some of them don't hold water, and it's only when you meet real customers and kind of have them try what you do and give you feedback, and meticulously collecting that feedback and refining your ideas and your methods to address the pain that the customer has is incredibly valuable. And Ryan picked it up very quickly and has done it extremely well. So that it's part of starting any business, and it's particularly important in a kind of a new category like data observability.
Yeah, I think 100%, with the customer feedback, with the customer, that importance to the customer, when you have those insights coming from them, it kind of makes a lot of difference for your product as well. And how you apply it there kind of takes you a long way. And that's how we've seen with Monte Carlo, obviously, being one of the strongest vendors out there in the data observability space. So kudos to the team. I'm sure you guys are hustling around. It's just that it takes a lot when you have to get the right feedback from the customer as well, and then implement and work towards it. So well done on that. But Ryan, also you spoke about the book in the recent book. So obviously, it's time for us to announce the first winner as well. Let's go out and announce the first winner for those who put out hashtag Monte Carlo in the chat. Already 13 people who have put out. So let's do the first raffle, and this is what I was talking about, Lior, Ryan, that we'll be picking up winner. We also will be also be picking up second winner towards the end of the show. So folks who are have just joined, don't forget to type in hashtag Monte Carlo, and we'll be picking up the second winner in the same way towards the end. Let's do the drum roll here. Let's see who the winner is. The winner gets one print copy of Data Quality Fundamentals, the new book by Monte Carlo. Michael, Michael Suttle, congratulations. I saw you just, obviously, you were just checking in that will there be a recording? So, yes, there will be a recording, but congratulations on winning a print copy. You also get a chance to obviously read about the new book from Monte Carlo, which is the Data Quality Fundamentals. What I'm also doing is sharing a link with everyone who wish to quickly go and want to download the book. Here's the link for everyone to check out the book, so don't hesitate to go get the access. Monte Carlo has been kind enough to keep it open for everyone out there, and there's the link. Go and check out the book. Awesome. Some questions around the book, obviously, but before getting into the book, one question that I had for both of you was, we've seen and heard so much, also according to Gartner, data quality is costing companies millions every year. So how do you plan to help companies with this? Like, I'm sure you'll be telling a lot around what and how you've mentioned everything in the book, but just in general, how are you looking at those problems and how are you solving those problems for the companies out there?
Yeah, I can get started, and then Ryan, I'm sure you'll have a lot to add. Um, it's so again, we're borrowing practices that are well understood on the software engineering side and on the DevOps side. But basically, the idea is that data downtime is essentially a function of three things. It's first, like, how many incidents you have. An incident refers to something in your system that creates unreliable data, right? And it could happen for a variety of different reasons. It could happen because one of your data sources changed in a way that you don't expect, or it could happen because someone pushes a code change that has unintended consequences, or it could be an operational issue in one of the pieces of infrastructure that process data. Whatever it is, there's like this number n, like how many incidents you have, right? And then when you do have an incident, there's kind of two factors that really matter. One is what we call time to detection, which is how fast you can tell that you have an issue, right? As long as you don't know you have an issue, you have data downtime, right? It's lingering. And the other part of it is like, how fast can you solve the problem? How fast can you resolve the issue once you've learned that it exists? And that's called time to resolution. Yeah. The approach to and remember, our goal is to minimize data downtime, right? So these are the three levers that we have. And so the solution to data downtime, it's called observability. We can talk about what it means DevOps, but the objective is to minimize those three parameters, right? And the first one, that's kind of maybe the most straightforward to understand, is time to detection, right? How long is it before, when you have a problem in your system, how long is it before you know you have a problem? And the way you do that is you start collecting a lot of information about the system, a lot of metrics and metadata and logs of all the different parts of your data stack, whether it's the data warehouse or the ETL tool or the BI tool, or really any part of it. And you start monitoring all that information for changes, right? Simple example, you can look at what we call data freshness. So basically, in a typical data system, every piece of data, every data set will get updated, a certain number of times per day or per hour or whatnot. You can actually track that metric, freshness, and create alerts to the people that build the system when a certain piece of data stops updating as you expect it to, right? That's a very simple example. Of course, you can get more and more sophisticated and start looking at the data itself and various constraints that you believe should be true about your data, but fundamentally monitoring the data and observing what it's been like, and alerting when it deviates from your expectations, is the kind of first step towards solving data downtime, right? If you know that something is happening, you can actually react to it, you can fix it, you can communicate about it, and minimize data downtime. The second part that we tackle is the time to resolution piece, right? Like, how long is it? Once you know you have let's say you get an alert, hopefully from your observability tool, but worst comes to worst from angry consumers of your data. And how long is it before you can actually pinpoint and address that issue, and resolve it, and backfill if you need, and kind of get to a state of good data. The way you do that, or the way you can help people do that, is by it's actually pretty similar, by collecting all the information that I talked about, all of that metadata and logs and metrics, and making it really easy for the people that are managing the incident to start correlating this information, right? Okay, so I have a freshness problem, but what is the process that has been updating that table? How has it worked in the past? What is going on there right now? Are there any errors or issues? Are there any changes to that system that's updating the table? And so forth and so on. And so by helping people understand how all the dependencies, lineage essentially, works in the system, and how each component is working, and all the different changes and errors and issues that happen with it, you can actually help people get to an answer much faster, and resolve the issue much faster, right? So you can actually take it from weeks. Oftentimes we talk to our customers, it takes them weeks to figure out what's broken in the data system. You can actually shorten that to minutes if you have all the information in one place, in a way that allows people to correlate and understand how all the different pieces work. And then there's, once you've addressed, and once you're able to detect issues and resolve issues, there's also this question of like, okay, why do I have those issues in the first place? How can I reduce the number of issues that I'm experiencing, right? That's the other big factor here. And so you can think about tools that help you understand the architecture of your system, the dependencies, what are the critical assets that you have, what are the parts that are being most used, what are the parts that are most likely to break, how long does it take to address issues in various components. So you can start thinking about your architecture, about how to simplify it, about how to streamline workflows, how to streamline processes, how to streamline teams, so that you fundamentally improve the reliability of your system in kind of a more proactive manner. So that's the high level. Of course, there's a lot of detail to that, but Ryan, if you have an example or anything to add, that'd be great.
Yeah.
No, I think you've done a really good job spelling it out, right? There's prevention, time to detection, time to resolution. Data downtime, the cost of data downtime to a business is just quantified by those, right? So pretty much everything we do on product is aimed at solving one of those verticals. Lior mentioned freshness detection, or data freshness as a problem. So freshness detection is something that we work on the data science team here, which is really just it's an unsupervised machine learning problem. This table, updates like this, and there's a delay in its update. Is that delay a cause for concern? Maybe yes, maybe no. And you have to kind of be careful about that, right? Because if a table only updates on weekdays, you might think it updates once a day. But you don't want to detect on an event on Saturday if it's just not going to receive data on the weekends. So the classic like time series anomaly detection problem there. Actually, in the book, chapter 4 of the book, there's a bit of a deep dive into some of these technical concepts to kind of see under the hood of anomaly detection for data freshness issues, and some of the other pillars of data observability, we call them. So like distribution's another one. What's my rate of null values in this table, or what's my rate of unique values? You can ask questions like, is the fields that contains the credit card hash ever null? Because if it's null, you can't bill off of that row, right? Or if a value is non-unique when you expect it to be unique, you might have some operational issues stemming from that. Actually, we know for a fact that big companies like Netflix has had issues like this before, where they thought tables were fully unique. They actually contain duplicates, and that just fully broke an entire system. It's a result of a data downtime problem. But Lior spelled it out super nice. There's all sorts of things to get into with data freshness, the lineage of different sources, things like the root cause that you can track through the course of an incident, and preventative measures too. The type of questions of like, we'll see customers where we have monitors set up where we'll say, okay, here's a table that updates once an hour. We can tell from the query logs that the query is getting longer and longer every time it runs. So you might not have a problem now, but you're about to have a problem because this table updates once an hour and the processing takes 57 minutes or something. So like we're running into danger here. You can do all sorts of observability in those different categories. And yeah, the book kind of dives into different verticals in a lot more detail than we can say here. So I'd invite you to check that out, basically.
Yeah, very cool. Thanks for sharing those points, Lior, Ryan. I think those are like the secret sauce points that you just bring for the folks out here, and appreciated getting into those detailings because it kind of helps the folks who kind of want to learn more about the space, about data observability, and this kind of brings them closer. We also have a few questions. I'm surely gonna ask you what kind of inspired you to write the book and all of those things, Lior. So, but before that, let's take a few interesting questions here. We had a comment here from Sean. She says data quality is the key to develop all good data products. We all agree. Awesome. We had a question here from Emmanuel. Let's take this one. How does Monte Carlo address issues of downtime during data migrations where data sources switches from one system to another? Very interesting question.
Yeah, that's a great that is a great question, and actually Monte Carlo has been used extensively to help data migrations complete successfully. Not necessarily in the way that you'd expect, in the sense of actually validating the new system versus the old system, but the way a solution like Monte Carlo helps is first and foremost by helping you understand your current system so that you can actually plan a successful migration, right? So a couple of the things that are particularly helpful. One thing is that a good observability solution will automatically reconstruct your system's lineage, right, all the way from sources and to data products, right, to the dashboards. It won't only do that; it would actually help you understand what are the most used or important assets in that entire graph, if you will, right? And in a mature data system, we typically find thousands of different data tables and sometimes tens of thousands of reports, and sometimes hundreds of machine learning models. And if you're trying to migrate something like that, good luck. Where do you even start? How are you even going to validate that the new system is working the same way the old system did? If you have access to lineage, if you have access to your most critical assets, you can actually plan your migration, right? You can certain milestones. You can actually understand, if I migrate this asset or this pipeline to the new system, these are the dependencies that I need to validate. These are the dependencies that could be broken, right? And so having observability in place as you do the migration is kind of a force multiplier in a sense.
Okay. That's, I'm sure that answers for Emmanuel. Very nice question, Emmanuel. Thanks for those insights, Lior. Another quick question here. Obviously, Kate is from Kate, but she also had a comment. She's looking forward to the Impact 2022 later next month. I'm looking forward to that as well. I saw the lineup. It's absolutely fantastic. Anything that you want to talk about Impact, Lior?
Oh yeah, it's a very exciting conference. I had a great
Yeah.
time last year, and this year, it was hard, but we tried to surpass and top what we did last year. So we have a great speaker lineup. Some of the people that are going to talk there are Nate Silver, the author of 538, and a bunch of great
Wow.
books about how to use data, and Nobel-winning. Um, Professor Kahneman, who wrote a bunch of great books that use data to actually answer questions about human behavior. Not a
Mm-hmm.
straightforward thing to do, but we're also going to have great people from the modern data stack industry. So the CEO of Databricks is
Wow.
going to be there, CEO of Fivetran, of DBT, and many other crazy interesting people that have done great things with data. So I'm personally looking forward to it. It's less than a month out, and we invite
Yeah.
everybody to join in.
Awesome. It's definitely a great lineup. I already saw it. I've registered. I'll be there and can't wait to obviously look forward to it. Also, Kate had this question about Monte Carlo. How does Monte Carlo differentiate from its competitors? Very interesting.
Good question. So I would argue, probably the TLDR is Monte Carlo is probably like the only data observability solution. There's a lot of tools out
Mhm.
there that would help you manage data quality and data reliability. Um, all of them fall into the category of testing or monitoring. And I'll explain what it means and how it's different from observability. Um, Testing and monitoring are a very effective strategy to start putting reliability into the system, right? Testing basically means you're going to write a bunch of predefined logical conditions that will, fire off or break your pipeline if they fail. So, like a very simple example, um, if you have an ID column that you really care about, you might add things like, once the ID column is calculated, let's make sure it doesn't have nulls. Let's make sure it's unique. Things like that, right? And that's great at doing that sanity checking and making sure that the basic things that the developer understands could break, making sure that they're not breaking. So that's kind of the first layer. Um, then you start getting into monitoring, where you start saying like, hey, I'm going to start taking, a few metrics about my system, typically a few metrics. So, maybe I'm not going to break my pipeline or write full tests about everything, but I might want to make sure that, but I might want to track the volume of records that I have for my users table, and make sure, and maybe I'll even put alerting there to make sure, hey, it doesn't cross, I'm not getting fewer than whatever 1,000 users a day, because I know I'm going to have at least several thousand users every day, and maybe I want to know it's not crossing 10,000 users a day, right? Maybe I might even use a basic kind of machine learning algorithm to make reasonable predictions there rather than setting thresholds. So that's the monitoring piece. Where observability comes in and where the real power of Monte Carlo is compared to alternative solutions is in that idea of optimizing all three parts of the data downtime equation, right? So testing and monitoring are focused on time to detection, right? Like, how do you make sure you know about issues? And they're also limited in scale in the sense that you have to predefine everything. Like, you have to predefine what are the metrics that you want to collect, and like what are
Mhm.
the cases where they would alert or break the pipeline. Observability is about collecting all of those metrics across the entire pipeline automatically out of the box, and also augmenting that with the logs and the metadata and the integrations across all the different parts of the stack to make sure that you can not only optimize TTT, but also time to resolution and the overall number of incidents that you have. And so it's kind of a fundamentally different solution that's designed for far more scale, if you will. And so like a mature data team would really need observability. Whereas earlier in the process, you could probably do well with testing and monitoring alone. So that's kind of how we view it.
Very cool, Lior. Thanks for that. And nice question, Kate. Thanks for asking that one. Kind of brings up a lot of insights. Okay, coming back to obviously the book, I wanted to understand a bit what will readers learn in data quality fundamentals, and what are the most important topics that are covered in the data quality fundamentals. Right? Maybe you can tell us more about the book.
Yeah. There's a lot to talk about with the book. It's an extensive work. I mean, everyone who contributed to it added a lot of kind of years of thinking. So there's really too much to say. What we've tried to do in the book is divide sections that sort of map the journey towards data observability, so that you can learn about, first what the problem is, and then sort of get a grasp for the vocabulary. Go through some of the kind of best practices from a technical perspective, and then also a more cultural perspective, like in terms of the types of operational moves you would do as a team to optimize for data observability. So just kind of cherry picking from the book, chapter 1 kind of talks a lot about, okay, what is this new problem? What's data observability? Why do we care about this now as opposed to 10 years ago? And how does it differ from monitoring and alerting, kind of just as Lior has just explained for us a second ago. Chapter 2, you'll start talking about, okay, what vocabulary am I using here? So you start getting into the weeds of actually resources you could get elsewhere, but like, what's the difference between a warehouse and a lake? What is ELT versus ETL versus reverse ETL? And when would I use each? What are the typical layers in the modern data stack? So we talk a bit about how integration layers work. And we talk about, the structure of data in warehouse systems, and kind of give a sense for the ecosystem, so you know which component pieces you're building with. The BI layer as well, integration with BI and analytics. Chapter 3, we talk a lot about best practices for data cleaning, data pre-processing, the types of things to look out for, certain pitfalls like checking against null rates, and how to sample from distributions effectively. A chapter that would be useful for data professionals, including machine learning engineers. Chapter 4, we're like in the weeds talking about some anomaly detection techniques. You actually do get to experience kind of implementing your own data observability solution firsthand in some SQL that's pretty accessible, so it doesn't rely on any particular toolkit that is new or transient, say. And I mean, I could keep going, but I think the sense you get is that there's a lot of these little verticals in the book, whether you're an executive who's used to looking at data from the top level and understanding its impact on the business, or whether you're a data engineer and you're really down in the trenches and like firefighting operational issues as they come up. I think the book's got something for all of those different personas, and it sort of paints a picture of how we've thought of it, what we've done so far, and sort of where we're going, how we expect this field to evolve as the industry moves more cloud native, more data focused.
One of my favorite parts of the book, by the way, is we actually took the time to bring a lot of real world case studies of how companies dealt with data quality. So you'll find, interviews and narratives of how companies like Fox, for example, that is, I think, the largest Redshift deployment on the planet, how they approach data quality and data observability. We have leaders from companies like Slack and Facebook and Airbnb explaining how they tackled it, in their companies. And so the book actually goes, beyond the Monte Carlo approach to things, and actually gives a thorough survey of how the industry as a whole is tackling it, and really tries to pick out the best ideas and the best approaches that have been battle tested in recent years. And so it's really kind of a nice guide, and like Ryan says, it can cater to both leaders that are guiding their teams and their strategies, but also to people that are building the systems hands-on with a lot of kind of practical advice on how to make those systems more resilient and reliable. So really enjoyed working on this book.
Okay, fantastic. Yeah, I know. When I was looking at the book on the Monte Carlo website as well, yeah, I guess it's the last chapter 9, data quality in the real world. So those are like that chapter is really interesting, and we on the same page on that, Lior. I kind of like that chapter as well. So for those obviously who wish to learn more about the book, obviously we're doing the giveaway, but for everyone, it's available on the website. And I did share a link with you guys here, so you can actually go and tune in. You can just go and access the book for free and learn more about data quality. That brings me to one very important question, is around the data quality itself. But how does the future look like for teams when it comes to applying data observability and proactive approaches to tackling data quality? What do you guys think about that?
Ryan, do you want to go first?
Yeah. I'll try to keep it brief. There's a cool future ahead. I think this conversation is just getting started. The book is a great kind of instigator for this type of conversation. What are the best practices? How do we put structure and vocabulary to this problem of data quality and data observability? I think there's a lot spelled out there in how we have sort of learned to deal with this problem up until now. But there's still work to be done at Monte Carlo and everywhere. I mean, I know that firsthand. There's a lot to be done at Monte Carlo. In terms of the novel approaches we can do towards more intelligent root cause analysis, better detection algorithms, better integration across like a whole lineage of different data platforms and integrations. So we can kind of ever more improve upon better prevention, better time to resolution and detection. That's a massive kind of unsolved problem. I'm honestly just excited for what this book's going to start in terms of a dialogue on the best practices in the industry for it.
Okay, pretty cool.
I would add just my 2 cents here. I think, like Ryan said, there's a lot more that we're going to do in terms of building capabilities and enhancing, and giving data engineers superpowers as they try to make their system reliable. I think the biggest change that we're already seeing that I think will reinforce itself in the next few years is just the adoption of an ops practice, right, and data observability in particular, right? If you're a software engineer listening, you probably can't imagine even building a pet project without having certain DevOps practices in place, including monitoring and observability, right? Like you wouldn't even imagine, doing your job without it. And I think we're going to get there on the data side as well. I think data teams are going to feel uncomfortable building without having strong practices and strong tooling to proactively manage the reliability and the trustworthiness of their end product. And foundationally, it's the biggest change of all, right? Like you can use Monte Carlo, you can use other methods to accomplish that, but I think the most important thing is just think about it. It's a foundational part of what you're doing, right? If it doesn't work, in some sense you didn't do it. And so just starting to think about it, how to make it reliable, how to measure that, how to proactively improve upon it, I think is the most important piece. And I see data teams are kind of doing that across the industry.
Okay. Pretty cool, interesting insights, Ryan, Lior. Obviously, before we jump on to our next winner, announcing our next winner, I wanted to ask what's next big thing for Monte Carlo?
Wow, so many things. But from Monte Carlo's perspective, we're very excited about continuing to better support our customers' stack, right? And we started out in the early days from data warehouses, and then we expanded into BI tools and data lakes. And this year we released our our Databricks integration, and we're the only solution that fully supports Unity Catalog and Data Tables and all that great innovation from Databricks. Going forward, we are continuing to deepen our support for dbt and Airflow, which are such an important part of the modern data stack. We're also going to support streaming solutions, or a lot of our customers are adopting streaming for various use cases, and creating observability into that is going to be critical. So that's it from the kind of, those are the near-term exciting items on the stack coverage side. And then as Ryan said, we're continuing to create powerful tools for people to correlate all that information to accelerate their process of diagnosing and solving problems, and getting them back to the things that they love to do best, which is build data products.
Awesome. I think, Lior, you've summed it up very well, and I really like the approach where you bring the customer first. You have that approach at Monte Carlo, and really appreciate that. I'm sure your customers are super happy that way. Awesome. So it's time for us to go out and announce the second winner. We already have 20 entries. Our first winner was Michael. Michael, congratulations. Let's go and announce the second winner. The second winner gets a data quality fundamental print copy. So let's do the raffle here. All right. If Michael wins again, we can draw again. So let's see. Okay, Chetan Divanji, congratulations. You win the data quality fundamental book by Monte Carlo. And for those obviously who couldn't win today, you can still go and check out the book online. It's available for everyone. I've shared the link again with you guys in the chat. So don't hesitate, go read out. I think I absolutely love the book. I had also shared it when, a few weeks back when it was published. So I highly recommend to read this one. Thanks to you for writing, and to the whole Monte Carlo team for coming up with such a great book out there for everyone, all the data engineers, aspirants. So very, very cool work. One last question for you both today. I know you guys have shared amazing insights, all the stuff, but if people still have questions for you, I know we might have not taken all the questions, but if people have questions for you and wish to reach out to you, where can they reach out to you? Lior?
So first of all, thanks, Ravid, for having us on the show. It was a lot of fun. I really enjoyed the questions and the people. If anyone has any questions or wants to connect, you can find me on LinkedIn, actually, Lior Gavish, Gavish. I know it's a difficult last name, but you're more than welcome to find me and connect with me and write. I'm also available. If you go to the MonteCarloData.com website and reach out to our team, they'll happily connect you with me. So yeah, looking forward to hearing from everybody. would love your feedback about the book. Obviously, if you have any thoughts, things that were particularly useful, or more importantly, things we could have done better. We welcome all feedback.
Awesome. Amazing. Ryan, where can folks reach out to you?
Yes, so LinkedIn's also a good platform for that. Actually, you can probably find me tagged in some of the Rabbit Show announcements about this exact talk. It's a good place to go. And on Medium as well. I think you should be able to find my Medium profile as Ryan Kearns. I write a bit about this type of stuff and publishing blog posts with Monte Carlo that are sort of bite-sized takes on this same general idea that you get in longer form in the book. So happily check those out. And of course, we welcome any feedback about that writing. We'd love to hear it. Thanks.
Awesome. Thank you very much, Lior. Ryan, such a pleasure to have you both on the show. And thank you everyone for joining us today and asking some amazing questions. Feel free to reach out to Lior and Ryan on LinkedIn. And you can also check out their Medium. You can check out the book on Monte Carlo website. I've shared the link. Thank you, everyone. Have a great evening ahead. Take care.
Thank you, Rabbit.
Thanks, Rabbit. Thanks, everyone.